From space, Antarctica looks almost unfinished. It is a continent nearly erased by white. No forests, no cities, almost no visible rivers, and across most of the interior, barely any sign that there is even land underneath. The Antarctic ice sheet covers nearly 14 million square kilometers and is about 2 kilometers thick on average, making it the largest single mass of ice on Earth. So, if you could somehow remove all of that ice, you might expect to find a giant, flat, frozen desert underneath. But that is not what Antarctica looks like at all. Buried beneath kilometers of ice are mountain ranges, valleys, enormous basins, ancient river systems, deep canyons, and hundreds of lakes that have spent thousands or even millions of years completely cut off from the surface. Modern mapping has revealed an entire hidden continent whose landscape is so dramatic that in some places it looks more like the Alps than the featureless white plain sitting above it, and some of these features are so deeply buried that humans have never actually seen them with their own eyes. We know they are there because scientists have learned how to look straight through the ice. That begins with aircraft. For decades, research planes have flown back and forth across Antarctica carrying ice-penetrating radar. The aircraft sends radio waves downward through the ice. Some energy reflects from internal layers, while another signal eventually bounces off the bedrock underneath and returns to the aircraft. By measuring how long that signal takes to come back, scientists can estimate the thickness of the ice and the elevation of the ground beneath it. Imagine walking through a completely dark room while repeatedly shouting and listening for the echo. A nearby wall sends your voice back quickly. A wall farther away takes longer. Radar does something similar, except instead of mapping a dark room, scientists are mapping an entire continent hidden beneath kilometers of ice. And the amount of information collected has become enormous. The latest BedMap 3 project combines decades of surveys with tens of millions of additional measurements and roughly 1.9 million kilometers of survey lines, giving scientists their most detailed continent-wide picture yet of Antarctica's hidden bedrock. Once that ice is digitally removed, Antarctica changes completely. Instead of one smooth continent, huge sections of the bed lie below modern sea level. Mountain chains rise between enormous depressions. Deep troughs carve inland from the coast, and some areas that appear connected at the surface are separated underneath by enormous buried basins. But one of the strangest discoveries sits deep in East Antarctica, the Gamburtsev Mountains. If you were standing above them today, you would barely know they existed. The surface is mostly ice. Yet roughly 3 kilometers underneath are sharp mountain peaks and deep valleys that resemble a massive alpine mountain range. Radar surveys show classic mountain terrain shaped by ancient rivers and glaciers before the modern ice sheet buried it. That alone creates a bizarre question. How do you hide an entire mountain range? The answer is time. Antarctica was not always the frozen world we know today. Tens of millions of years ago, the continent was warmer. Rivers flowed across parts of the landscape. Vegetation existed in regions that are now buried beneath ice, and mountain valleys were exposed to the atmosphere. Then, Earth's climate changed. Large-scale Antarctic glaciation began around 34 million years ago, and the Gamburtsev Mountains appear to have been one of the places where major ice growth began. As snow accumulated in the high elevations, glaciers expanded through the valleys before eventually joining into much larger ice masses. Eventually, enough ice accumulated to swallow almost the entire mountain range. But instead of grinding every feature completely flat, parts of the buried landscape were preserved. Radar reveals deep valleys, sharp ridges, and other recognizable mountain forms that have survived beneath the ice for millions of years. In some places, the ice essentially became a gigantic freezer for landscapes that disappeared from the surface long before humans existed, and the Gamburtsevs are not the only example. In 2023, scientists studying East Antarctica described another remarkable buried landscape beneath the ice. They found an extensive network of valleys and elevated blocks that appears to preserve an ancient river landscape from before the modern Antarctic ice sheet formed. The branching pattern of those valleys looks like something water once carved across an exposed surface. Some valleys stretch for tens of kilometers, and the landscape appears to have survived beneath the ice because the ice above it remained cold enough at the base to freeze onto the ground instead of constantly sliding across it and eroding everything away. That means parts of Antarctica may contain landscapes that have barely changed for millions of years. Imagine burying an entire river valley beneath several kilometers of ice, leaving it there through the rise of humans, the building of every civilization in history, and almost every major change in the modern world, then discovering its shape without ever digging it up. But mountains and ancient rivers are only part of what is down there. Because underneath Antarctica, there is also liquid water, a lot more of it than you might expect. More than 400 subglacial lakes have been identified beneath the Antarctic ice sheet. Some are relatively small, while others are enormous bodies of water sitting in permanent darkness beneath kilometers of ice. The most famous is Lake Vostok. It lies deep beneath East Antarctica and stretches roughly 200 kilometers in length. Above it sits an enormous thickness of ice, separating the water below from the atmosphere at the surface. The first time you hear that, it almost sounds impossible. How can there be liquid water underneath one of the coldest places on Earth? The answer is that the bottom of the Antarctic ice sheet is a very different environment from the top. Ice is a surprisingly effective insulator. The surface can experience extreme cold, but kilometers of ice help trap heat coming from Earth's interior. Pressure from the enormous weight of the ice also changes the conditions under which water freezes, and in some places friction from moving ice adds additional heat. Together, those effects can allow water to remain liquid at the base. The result is something like a hidden plumbing system beneath the continent. And these lakes are not necessarily isolated swimming pools sitting motionless forever. Some of them fill, some drain, and some appear connected by channels beneath the ice. Scientists discovered this by watching the surface from space. If a hidden lake several kilometers below suddenly receives more water, the ice above it can rise slightly. If that lake drains into another part of the subglacial system, the surface can sink. NASA satellites have measured these tiny elevation changes and used them to identify active networks of lakes beneath West Antarctica. Some lakes have been observed exchanging water even though everything happening below is completely invisible from the surface. Think of placing several balloons filled with water underneath a thick mattress. Move water from one balloon into another, and the top of the mattress changes shape. The Antarctic ice sheet is obviously much larger, but the basic idea is similar. Scientists can watch the surface move and infer that water is traveling underneath. And that hidden water matters because the ice above it is not stationary either. Antarctica's ice is constantly moving toward the ocean. Some regions creep slowly. Others form fast-flowing ice streams that carry enormous amounts of ice toward the coast. Liquid water beneath the ice can reduce friction between the ice and the ground, effectively helping sections of the ice sheet slide more easily. Researchers have found major subglacial lake systems near the beginnings of some fast-flowing ice streams, which suggests that buried water can influence how quickly ice moves toward the ocean. So these hidden lakes are not just strange, isolated environments. They are part of the machinery controlling Antarctica itself. And then there is an even more obvious question. If a lake has spent an enormous amount of time buried beneath kilometers of ice, completely separated from sunlight and the surface world, could anything actually live there? Scientists have already found microbial life associated with subglacial environments near the margins of Antarctica, showing that organisms can survive beneath the ice without sunlight. Instead of using photosynthesis, microbes in these environments can obtain energy through chemical processes, but the huge lakes buried beneath the deep interior remain much harder to study directly. Drilling into one without contaminating it is incredibly difficult. You cannot simply lower an ordinary drill through several kilometers of ice and dump surface microbes, fuel, chemicals, and equipment into an environment that may have been isolated for an extremely long time. Any serious attempt to sample these waters has to be done carefully enough that scientists do not destroy the thing they are trying to study. That makes some of Antarctica's hidden lakes interesting for another reason. They may provide one of Earth's closest analogs for environments that could exist elsewhere in the solar system. Jupiter's moon Europa and Saturn's moon Enceladus are both believed to contain water beneath ice. If life can survive in permanent darkness underneath Antarctic ice by relying on chemical energy instead of sunlight, scientists want to understand exactly how. But if you removed Antarctica's ice completely, the lakes would not be the only thing that surprised you. The coastline itself would look dramatically different. Large areas of West Antarctica rest on bedrock that is below sea level. Some enormous basins extend deep inland beneath the ice. Modern bedmap mapping highlights just how much of the hidden continent sits below today's ocean surface. So Antarctica is not simply a giant rocky table with ice piled on top. In some areas, the ice is covering deep depressions that would become marine environments if the ice were somehow removed and the land did not rebound. And this geometry is extremely important for the future of the ice sheet. When a glacier rests on bedrock below sea level and that bed slopes downward farther inland, warm ocean water can potentially reach underneath floating or grounded ice at the margins. That can make certain sections more vulnerable to retreat. This is why scientists care so much about mapping a landscape nobody can see. Every hidden ridge, valley, and basin can change the way ice moves. A mountain beneath the ice can act as an obstacle. A deep trough can guide ice toward the ocean. A ridge can help stabilize a glacier. A basin extending inland below sea level can create a route through which retreat may continue. So when scientists map Antarctica's buried terrain, they are not just creating a cool picture of what the continent would look like without ice. They are trying to understand how the world's largest ice sheet might behave in the future. That ice sheet contains an astonishing amount of water. Earlier bedmap estimates put the potential global sea level contribution of the Antarctic ice sheet at around 58 meters if all of its ice were somehow transferred into the ocean, although that is not a prediction of what will happen. The point is scale. Small changes in such an enormous system matter, and the hidden landscape underneath helps determine where those changes happen first. There is one more thing that makes this buried world especially strange. We still do not know every detail. Even BedMap 3, despite incorporating an enormous amount of new data, is partly an interpolation between survey lines. Antarctica is huge. Scientists have flown millions of kilometers of radar surveys, but they have not scanned every meter of bedrock with perfect resolution. BedMap 3 itself combines measurements from decades of work and many different surveys to construct the best continent-wide model currently available. That means there may still be valleys, smaller lakes, geological structures, and other features whose detailed shapes remain unknown. And improvements in radar are making those hidden landscapes sharper. Newer techniques can map wider swaths of the bed beneath aircraft rather than only producing one narrow line directly underneath them. Researchers using this kind of mapping have revealed detailed U-shaped valleys, alpine terrain, and candidate subglacial lakes beneath regions like Hercules Dome. Each improvement is essentially peeling away another layer of the ice without physically removing any of it. Which brings us back to what Antarctica really is. From above, it looks simple, white ice stretching to the horizon. But that surface hides one of the strangest landscapes on Earth. There are mountain ranges completely buried beneath kilometers of ice, ancient river valleys preserved from a warmer world, enormous basins extending below sea level, hundreds of lakes sitting in permanent darkness, networks of water moving between them, and possibly ecosystems surviving without ever seeing sunlight. The ice does not erase Antarctica's landscape, it hides it. And because some parts of that landscape have remained protected for millions of years, looking beneath the ice is almost like opening a geological time capsule. Those buried mountains tell us where the first major Antarctic glaciers may have formed. The ancient valleys preserve clues from a continent that once looked completely different. The lakes reveal an active world of liquid water beneath what appears to be solid ice, and the deep basins help determine how the ice above them will behave as the climate changes. So, if Antarctica's ice suddenly vanished, we would not discover one giant frozen plain. We would reveal an entire hidden continent, one with mountains, lakes, rivers, valleys, and landscapes so old that some of them may have been sealed away since long before the first humans ever existed. And the craziest part is that we are still mapping it.